Thanks very much for inviting me to join you today. I am the Climate Change Coordinator in the Department of Environment, Labour and Justice. And for me, that role kind of has two parts to it. I deal with the entire issue of climate change, so that means that I'm involved in the mitigation side, which relates to reducing greenhouse gas emissions, and also the adaptation side, which deals with preparing for climate change. And in the last couple of years, the adaptation side of my work has been what's taken most of my time, and a lot of that has had to do with the project that we've been involved with Natural Resources Canada called the Regional Adaptation Collaborative. So the Atlantic provinces have partnered with each other as well as with Natural Resources Canada on the Regional Adaptation Collaborative, or the RAC, as we call it. This was a 3-year program. We received between the 4 Atlantic provinces about $3.5 million and matched with $4.6 million. Our collective is known as the Atlantic Climate Adaptation Solutions Association. So the purpose of the RAC, it's a nationwide program. There are RACs all over the country. We are one of the RACs that's actually a regional approach. The prairies have a regional RAC as well, and so do the territories. And the idea was that across the country, we would all be looking at issues that were relevant to us as a region. And for us, we thought we needed some help looking at climate risk and vulnerability and advancing climate adaptation decision making. So putting some tools and knowledge in the hands of local decision makers so that they can make good decisions about climate change adaptation. And basically there were a few different issues that we knew we wanted to address in this region. The first one dealt with coastal risk and vulnerability. This is an image of Parma Beach. Inland risk and vulnerability. This one is from Nova Scotia, looking at inland flooding. Looking at the risk to infrastructure. This one is out of New Brunswick. Helping communities do assessments of what their risk and vulnerability is to climate change. So this one's in Newfoundland, Logie Bay, Middle Cove. And then looking as well at the vulnerability of groundwater to sea level rise. This is a picture from PEI. This is in Anglo-Tignish, and that's a well casing that's sitting on the beach there, which is not terribly unusual in PEI. What made this one particularly interesting was that well casing was on the land prior to the storm surge on December 21st of 2010. So that chunk of bank went in that storm, exposing that casing. So you usually don't see them that tall, is what makes this rather interesting. So all of us as provinces have projects in each of these areas. A lot of them are very similar to one another. Some of them are not. As you can imagine, inland flooding looks very different in Prince Edward Island than it does in New Brunswick or Nova Scotia or Newfoundland. We don't have the large river systems that drive a lot of the inland flooding issues that the other provinces have. So they're all slightly different, but have a lot of commonalities to them. Today, when I was asked to come and speak to you about the work of the RAC, I thought I'm just going to focus on the coastal risk and vulnerability projects that we've been working on, as well as talk a little bit about some of the tools that we've been using to help us look at climate change adaptation. So when it came to coastal risk and vulnerability in Prince Edward Island, we were mainly concerned about two issues. Erosion, that's a picture from Stratford, and flooding. So it's a bit of an illusion here. Those boats look like they're parked on the land. that was on October 5th of last year. Not really damaging storm surge because it didn't have the wind associated with it, but the water level was quite high. So those were the two issues that we wanted to look at, erosion and flooding. And flooding along the coast could be driven by sea level rise as well as storm surge activity. So those were the risks that we wanted to address with our projects. To start with flooding, in order to get a good handle on flooding, one of the tools that we had at our disposal was LiDAR data. So in 2007, 2008, the province embarked on a province-wide LiDAR mapping exercise, where, which is, you see, light detection and ranging. It's a remote sensing technology where we have flights flown, there's laser beams that go down, the time that it takes to return to the aircraft is corresponded to the elevation of the land. So basically what you end up with is a map of the entire elevation of any particular place in PEI within an accuracy of about plus or minus 30 centimeters. So we had embarked on that project in 2007, 2008, prior to the RAC. So we had this basic information that we could use to start looking at risks associated with flooding. From that LiDAR data, which is an immense data set, sometimes people will call me up and say, I'd really like to get my hands on that LiDAR data. I said, no, you don't. You really have no idea. We're not talking about your average desktop that's going to be able to take this data and conceptualize it and show you something that you want to see. They take that data and generate a digital elevation model, which is a little easier to deal with. So this is a digital elevation model of downtown Charlottetown. And I believe this image was captured actually in 2000. There's been a couple different LiDAR activities go on within the province. The first one was in 2000 with a study by Natural Resources Canada on the impacts of sea level rise to the city of Charlottetown as well as to parts of the North Shore. So there was some LiDAR captured, and this is an image of the LiDAR from that project. So you can see the different elevations are color-coded. Blue is low, red is high. So it gives you an idea of the gradation of the land, and it gives more detail than what you could get in a contour map, which is kind of what we would have used before this to determine what the elevation was like. So we have, 2-meter contours within the province, so you can say, okay, we know that you're less than 2 meters in elevation, but we don't know whether you're half a meter or whether you're 1.5 meter. You're just below that 2-meter contour. Then, of course, as I mentioned, we did our island-wide. And then there was another series of LiDAR that was flown in 2011, and it had to do with some projects going on with the Canadian Wildlife Service and looking at piping plover habitat, and them wanting to know the vulnerability of some of those habitats and whether they needed to start looking at purchasing land further inland in order to provide habitat to protect that species. So here is what we've done with some of the LiDAR data and the digital elevation model. This is North Rustico, and this is a hazard map that we're working on now for 2050 time frame. So the green is 50 centimeters of sea level rise, and then you can see storm surges on top of that, so ranging from 1.1 meter storm surge, which is a 1 in 10 year event, all the way up to a 1.6 meter storm surge, which is a 1 in 100 year event. So you can see the areas of North Rustico that would be particularly vulnerable in this scenario. And that's it's a really interesting tool to be able to take to a community. They love this when we take these maps to them. It's the best way I've ever found to liven up a conversation in a room, get people engaged in a conversation, is to pull out a map and put it in front of them. And so this is a really easy way for them to visualize what can be a really abstract concept. When you come into a community and you say, sea level rise is going to impact you, and you're going to have 50 centimeters of sea level rise in the next 50 years. Well, that doesn't mean anything to them unless you can show them, here's what we're talking about, here's where the water will be. And the LiDAR and the digital elevation model is the tool that makes that very real.
Erin,
Yes.
That your model here doesn't
Yes.
include coastline change or due to erosion.
It does not.
So some of those things would actually, because 50 years from now or 40 years from now,
Yes.
but that might not be significant.
Well, there'd be areas where it could be significant. There are parts of this shore that are armored. But yeah, erosion presents another complication on top of that, because then all of a sudden the shoreline has moved further inland. And if the elevation of that land is low, then you're going to see that flooding. Yeah.
Haven't I seen like storm surge and roll up numbers on the 1 in 100 years scale of in the 3 meter range?
I don't know if you have.
In previous presentations from the
No. These numbers we had was one of the RAC projects. We generated these scenarios, and Nova Scotia and PEI got together, and we developed. We had someone develop climate change scenarios for. There was 8 communities in PEI, and I think there might have been 14 communities in Nova Scotia, and that developed a whole suite of information and indices. So everything from temperature, precipitation, all the way up to storm surge information. So these numbers are from that study. They vary from community to community because the storm surge is dependent on exposure, and so depending on where you are on the island, those numbers are slightly different. But we're not talking about storm surges of 3 meters. Could be.
So
This
this
would
is
be
one
on
meter
top of.
above
This
high.
would be on top of higher high water, large tide.
Okay, so that's
Would that
the
include
difference.
plate subsidence?
Yes.
The plate going down?
Yes, this would be relative sea level rise, so it would have those 2 components of sea level rise and crustal subsidence, and then storm surge on top of that. So this is